Good afternoon, everyone. Let us start. Remember, we have been learning Chapter 5, Minerals and Energy Resources. Last time we discussed about non-conventional sources of energy, and today we shall learn about non-conventional. The last one was about conventional sources of energy, and today we shall discuss about non-conventional sources of energy. So let me present solar energy. So this is one of the non-conventional sources of energy. Let us read. India is a tropical country, and it has enormous possibilities of tapping solar energy. Okay, we have bright sunshine in most parts. Okay, and that is why enormous possibilities of tapping solar energy. We have photovoltaic technology converts sunlight into electrical energy. Okay, let me repeat. Photovoltaic technology converts sunlight directly into electricity. I think most of you are familiar with these solar panels. So let me show you a photograph. Okay, so this is an array of solar panels, and here so this is the array, and here we have panel, then we have module. Okay, and in the module we have many photovoltaic cells, that is PV cells, and these photovoltaic cells convert sunlight directly into electrical energy. Okay, and we are also using in the households. So this is one of the technologies, okay, of harnessing the sunlight. In addition to this, we have one more technology known as solar thermal technology. So in this case, what we have to do is we have to install a series of these concave, okay, a series of these concave mirrors. So for example, this is concave mirror. So using stand we have to install it. Okay, and so here we have to lay steel pipe filling with water or liquid, and see the sunlight, okay, is focused. So these are the rays of the sun, and it will be focused on this pipe. Okay, and here the liquid in the pipe will be boiled and will turn into steam at the terminal. The steam will be released, okay, will be released with a great force, and here if we keep a turbine, then the turbine will be rotated, okay, and if it is connected with the generator, then electricity is produced. So this technology is known as solar thermal technology. Okay, here we use concave mirrors, an array of concave mirrors. Okay, but in the households we are mainly using this photovoltaic technology, and in the solar power plants also, okay, we are using that this photovoltaic technology as well as the solar thermal technology. Okay, that one, see this one, this array of solar panels are related with the solar power plant, okay, installed in Algeria. So let us proceed. The solar energy is fast becoming popular in the rural and the remote areas, and some big power plants are being established in different parts of India, and which will minimize the dependence of rural these households on firewood and dung cakes. Okay. Do you hear me? Any problem? Any net problem is there? Are you connected?
Yes, sir.
Okay, so let us proceed. See here, because of use of solar power plants in the rural areas, okay, say the rural households say are relieved from the use of firewood and dung cakes, and these will in turn will contribute to environmental conservation. See, instead of these dung cakes and firewood, we're using solar energy. That means cutting of trees, okay, is reduced. Then at the same time, the dung cake can be reserved, okay, for use as manure in the agriculture. So in this way, by using solar energy, the dependence of these rural households on firewood and the dung cake is reduced, and this will in turn contribute to environmental conservation, and there will be adequate supply of manure in the agricultural field. So this is about solar energy. And you must know that in case of India, solar energy, okay, we have the potentiality in Gujarat and this Rajasthan area. So in these areas, we have this bright sunshine, and solar power plants can be set up, mainly in the states of Gujarat and this Rajasthan. So here, this is an example. Okay, this photograph shows the use of the solar energy. So it is used for this milk, okay, for running the milk testing equipment. Any question, boys and girls, from your side about the solar energy? Any question? So if you don't have, so let us proceed. Next, we have another non-conventional sources of energy, that is wind power. And India has great potential of wind power. The largest wind farm cluster is located in Tamil Nadu, okay, from Nagarcoil to Madurai. So India has one of the largest wind farm cluster in Asia, and this wind farm cluster is located in Tamil Nadu. Okay, it stretches from this Nagarcoil to Madurai. I think how wind power is harnessed is given here. See, so this photograph, okay, shows a series of windmills, and here I have one more this photograph. See here, these are the windmills. And when the wind blows, the turbine will be rotated, and it is connected with the generator. Okay, here on the back we are seeing generators. So these are the generators, and these generators these produce electricity. So in this way, wind energy is harnessed. And about the distribution of the wind power, so largest wind farm cluster is in Tamil Nadu. It stretches from Nagarcoil to Madurai. And apart from this state, okay, Tamil Nadu, we have Andhra Pradesh, Karnataka, Gujarat, Kerala, Maharashtra, Lakshadweep. So these are the states, important states having wind farms. then Nagarcoil and Jaisalmer. Nagarcoil is in Tamil Nadu, Jaisalmer in Rajasthan are well known for effective use of wind energy in the country. Okay, in Nagarcoil and Jaisalmer, wind energy is effectively harnessed. So this is about wind power. Next we have biogas. I think about biogas plants you might have learned in the science classes also. Okay, so let us read. Shrubs, then farm waste, animal and human waste are used to produce biogas for domestic consumption in the rural areas. The decomposition of this organic matter yields gas which has higher thermal efficiency in comparison to kerosene, dung cake and charcoal. So here we have this a cross section of the biogas plant, and here this side, okay, we have this mixing tank, and here we are this pouring, okay, dung, cow dung mixed with water and other waste materials. Okay, this is the inlet chamber, and here it is decomposition is taken place in this cylinder, okay, in this tank. So here we have digester, and so because of the this action of bacteria, it is decomposed, and biogas is released, which is highly inflammable. And here it is, we have a pipe connected to it, and so this biogas is ready for use for cooking and this lighting. Okay, so this is a schematic diagram of the biogas plants. And here biogas plants are set up at municipal, cooperative and individual levels. We can also install our own biogas plants. It can be installed set up in the municipal levels also. Okay, and the biogas plants using cattle dung is known as gobar gas plant. Okay, the biogas plant using cattle dung is known as gobar gas plants in rural area. And so these biogas plants provide twin benefits, dual purpose to the farmer in the form of energy and improve quality of this manure. So biogas plant, okay, provide twin benefits. So on the one hand it provides energy, okay, on the other hand it also provides manure. The decomposed matter, okay, can be used as a farm manure on the other hand, and on the one hand, and we get this highly inflammable gas which can be used in cooking and lighting. And here in our book also we have this photograph of biogas plant, okay, here. And biogas is by far the most efficient use of cattle dung, and it improves the quality of the manure and also prevents the loss of trees and manure due to burning of fuel wood and cow dung cakes. So after using biogas, okay, cutting off these trees is also reduced. At the same time, burning of cattle dung, these dung cakes also reduced, so that cattle dung can be kept say for this farm manure. And from the biogas plant also the residues can be used as this manure. So in this way biogas plant provide twin benefits, okay. At the same time the cutting of trees is also prevented. Boys and girls, do you have any question regarding wind energy, then biogas plant, solar energy? Yes. Yes, are you connected?
Yes, sir.
Okay, let us proceed if you don't have problems. So next we have tidal energy. Okay, you know, tide means this periodic rise and fall of sea level due to the gravity of the sun and the moon. Okay, and how oceanic tides are harnessed. Okay, let us read. Oceanic tides can be used to generate electricity. Here, this is the procedure, this is the method. Okay, floodgate dams are built across inlets. During high tide, water flows into the inlet and gets trapped when the gate is closed. After the tide falls outside the floodgate, the water retained by the floodgate flows back to the sea via a pipe that carries it through a power generating turbine. So this is the method okay, to generate electricity from the ocean tide. First, let me explain say about this tide. See here, this is a coastal area. Okay, and here this is a normal sea level. Let us say this is the normal sea level, and see due to this gravitational attraction of the sun and the moon, okay, the seawater is pulled upwards, and here say after pulling upwards, so this is the new level of the sea. So this position is known as high tide. Okay, so this is known as high tide. Then after some time, again the sea level may be falling down. So this is known as low tide. So this periodic rise and the fall of the sea level is known as a tide. Okay, it occurs twice, at least twice in a day. And now let us see how it is harnessed. Okay, here say let me draw you. So what to do? Say here we have to construct, okay, this tidal basin. So first let me find out, okay, where is the diagram? Here this is the diagram. Okay, here we have these berets. Okay, and here on the right side we have the tidal basin. So this is a big reservoir. This is a big reservoir, and when there is high tide, the ocean water level will be rising upward, and this will overflow these berets and will fill up this tidal basin. And after filling up this tidal basin, okay, the sea level may be falling downward. That is the low tide position. And at this time, if we open these floodgates, okay, these sluice gates or floodgate, then from the tidal basin this water is released with a great force, and this will rotate the turbine, and it will be connected to a generator, and the electricity is produced. So in this way this tidal energy is harnessed. Okay, see here this is the tidal basin, and here the water will fill up to here, and we have to make this tunnel here, and if we open the floodgate, then water will be released, and here if we rotate a turbine here, then electricity is harnessed. So in this way tidal energy is tapped. Okay, and about the potential areas in India, this Gulf of Khambhat and Gulf Kutch in Gujarat on the western coast in Gangat and the Gangetic Delta in the Sundarban region of West Bengal provide ideal condition for utilizing tidal energy. So potential areas of tidal energy are these Gujarat and West Bengal. Okay, Gulf Khambat and Kutch. See here, if say I think let us see a map of India. See here this is known as a Gulf Khambat, okay, and here this is the Gulf Kutch. This area and this area have this potential, okay, for harnessing this tidal energy. And next we have this geothermal energy. What do you mean by geothermal energy? See, geothermal energy refers to the heat and electricity provided by using heat from the interior of the earth. We know that the earth interior is very hot, okay. The geothermal energy exists because the earth grows progressively hotter with increasing depth. So when we get down into the earth interior by 30 meter, temperature will be increased by 1 degree Celsius, okay. That is the point mentioned here. Geothermal energy exists because earth grows progressively hotter with increasing depth, and where the geothermal gradient is high temperatures are found at shallow depths. Okay, geothermal gradient is high means where the rate of increase of temperature is high, then high temperatures are found at the shallow depths. Okay, then groundwater in such areas absorb heat from the rocks and becomes hot, and it is so hot that when it rises to the earth surface it turns into steam, and this steam is used to drive turbines and generate electricity. Okay, here we have a schematic diagram here. Okay, here here see in the mantle we have these magma chambers, okay, and sometimes this magma may be rising upwards and touching this aquifer, the layer containing water, and because of that this water turns hot and sometimes converted into steam, and this steam is rising upwards, okay, through the holes, and these hot steams can be tapped using steel pipes, and say these steams can be used to rotate the turbine here, and the turbine is connected with the generator and electricity is produced, and this water, okay, this steam again can be recycled after cooling here, okay, in the cooling areas, in these cooling plants, so it can be injected, the water, the cold water can be injected again into the underground. So in this way geothermal energy is harnessed. What to do? First we have to collect the very hot steams, okay, releasing from the earth's interior using steel pipes, and that steam is used to rotate the turbine is connected with generator and the electricity is produced, and again the hot water after cooling is again injected into the underground. Okay, so in this way this geothermal energy is harnessed. And about the distribution, see, there are several hundred hot springs in India which could be used to generate electricity, and 2 experimental projects have been set up in India to harness this geothermal energy, and one is located in the Parvati Valley near Manikaran in Himachal Pradesh, and the other is located in the Puga Valley in Ladakh. Okay, so these are the 2 experimental projects for harnessing geothermal energy, one at the Parvati Valley, another one in Puga Valley. Okay, So up to here, any question from your side, boys and girls? Are you clear? Are you clear? Am I connected?
Yes, sir.
Okay, let us proceed. So this is the last part, okay, conservation of energy resources. Here in the first two paragraphs, okay, the first two paragraph tells why conservation of energy resources are necessary, and in the last paragraph you will find the conservation measures, okay, the methods of conserving energy resources. Now let us have a quick look at, okay, see, energy is a basic requirement for economic development of a country. So every sector of national economy, like agriculture, industry, then transport, commercial, all these sectors need energy, okay, need input to energy. For example, industry also requires energy for running the machinery which are used in agriculture fields. We need energy. Industries also need energy to run the machinery. Transport and communication also. And the economic development plans implemented since independence necessarily required increasing amount of energy to remain operational. So to develop the economy of a country, we need more and more energy, okay, in different sectors, in the agricultural sector, in the industrial sector, in the transport sector, okay. As a result, consumption of energy in all forms has been steadily rising over the country, all over the country. And in this background, there is an urgent need to develop a sustainable path to energy development. So since the consumption of energy has been increasing day by day, at the same time, most of the conventional sources of energy like coal, petroleum, natural gas, okay, are exhaustible, and that is why we need conservation of energy resources. Okay, and now let us read how can we conserve these energy resources. The first important method to conserve these conventional conventional sources of energy is the use of renewable energy, okay, that is called substitution. The use of the conventional sources of energy like coal, petroleum, natural gas may be substituted, okay, by the renewable energy sources like solar energy, then biogas, then wind energy, okay, and so on, okay. And we say, as a citizen, as an ideal citizen, we have to adopt a cautious approach for the judicious use of our limited energy resources. So as a good citizen, we have to use the energy resources wisely. For example, as a concerned citizens, we can do our bit by using public transport system instead of individual vehicles. Instead of using our private vehicles, okay, motorcycles, then these cars, we better to use the public vehicles to conserve the fuel, okay. Then switching off electricity when not in use. This is another method. Then using power saving devices. This is another one, okay, using power saving devices. So now we have so many devices, okay, which consume less power. Say for example, use of these LED, then OLED monitors instead of CRT monitors, just an example, okay. Then it can be done. Then the last one, using non-conventional sources of energy. that is use of solar energy, geothermal energy, tidal energy, must be encouraged. After all, energy saved is energy produced. This is the slogan, okay? Energy saved is energy produced. So these are the different ways or the methods for conserving energy resources. The first point is that whenever possible, we must substitute the use of the conventional energy resources by non-conventional one. The use of coal, petroleum, natural gas may be replaced by the solar energy, tidal energy, biogas, then thermal energy. And as a citizen, we better to use the public vehicles, then switch off this electricity when not in use, then use of power saving devices. So these are different ways. So any question from your side?
No, sir.
Okay, then let us stop here for today. Don't forget to send your names for attendance. Thank you very much for joining my class.